Good day, learners! I am Miss Joy Q. Batang, your teacher for today's lesson. In this video, you will learn to illustrate how energy from volcanoes may be tapped for human use. Have you visited a hot spring? We love to enjoy the energizing and detoxifying feeling brought by the water of hot spring. The heat from the water can stimulate blood circulation, boost our metabolism, recharges our skin, and releases our stress. But the question is, where do heat from hot springs came from? Do you have any idea? Since our country lies in what we call Pacific Ring of Fire, a western rim of the Pacific Ocean, which is the most seismically active part of the Earth, is prone to intense volcanic activity and earthquake. Volcanoes are the main source of geothermal energy. Most geothermal systems are found in mature volcanic complexes, that's why energy has been tapped from them. But what is geothermal energy? Geothermal energy. Geothermal energy is a renewable energy that is harnessed from the heat inside the earth for human use. Geothermal comes from a Greek word geo, means earth, and therme means heat. Geothermal energy uses the heat trapped beneath the earth's surface to generate electricity. This heat comes from the center of the Earth, which is a byproduct of chemical and nuclear reactions happening in the Earth's core, occurring for billions of years. It slowly and continuously migrates up through the Earth until researchers and scientists reach it by drilling into the ground. Recently, Philippines ranks third in the world's production of geothermal energy. Our country's total power generation produced from geothermal energy is 13.4 according to the Department of Energy. The production of electricity from geothermal energy is cheaper than electricity production using natural gas, coal, and hydropower. But how do we harness the heat beneath our feet? To be able to harness geothermal energy deep in the earth, three things should be considered: heat, fluid, and permeability or pathways through the rock. The heat from the center of the earth migrates to the surface naturally and is found everywhere underground, although the amount of heat varies slightly from place to place. The fluid inside underground rocks absorbs heat and brings it to the surface. This underground layer of rock that is saturated with water is called aquifers, that can be brought to the surface through natural springs or by pumping. And lastly, permeability or pathways of water to flow underground are usually made up of fractures or cracks in the rocks, which are very tiny and connected. These fractures allows these fluids to circulate slowly and increase in temperature. With these three together, it can create a what we call geothermal reservoir. Geothermal reservoir is a volume of rocks in the subsurface which exploitation in terms of heat can be economically profitable. These underground reservoirs of steam and hot water can be tapped to generate electricity or to heat and cool buildings directly. The next underlying question is, how geothermal energy is generated? Geothermal energy can be generated in two ways. First, through geothermal power plants. It is where the heat from within the earth changes water into steam, which turns steam turbines that generate electricity. Geothermal power plants are built in an area where it is particularly hot just below the surface, such as near a group of geysers, hot springs, or volcanic activity. How geothermal power plant works. First, wells are drilled deep into the earth to pump steam or hot water to the surface. Second, when the water reaches the surface, the drop in pressure causes the water to turn into steam. Then third, the steam spins a turbine which is connected to a generator that produces electricity. Fourth, cooling tower cools the steam which it condenses back to water. And lastly, the cooled water is pumped back into the earth to begin the process again. Here are some geothermal power plants found in the Philippines. Tiwi Geothermal Power Plant in Tiwi, Albay. Kidapawan Geothermal Power Plant in North Cotabato. There are also geothermal power plants in Macban or Makiling Banahaw in Calauan, Laguna. We also have in Calaca, Laguna, Tongonan, Leyte, Bago City, Negros Occidental, Valencia, Negros Oriental, and Bacon, Sorsogon. Aside from geothermal power plants, geothermal heat pumps can also be used to tap energy from volcanoes. Geothermal heat pumps transfers heat into building by pumping water or a refrigerant through pipes just below the Earth's surface where the temperature is constant. So as you can see, the pump is installed on a concrete pad above the ground close to the home, and then the holes are drilled through the earth for dozens or hundreds of feet. The depth depends on the location of geothermal energy pockets in your regions. Then two sets of piping are connected to the pump and fed underground. The pump pushes cool surface water down through the pipes. So how geothermal heat pump works? First, the water or a refrigerant moves through a loop of pipes. Then, when the weather is cold, the water or refrigerant heats up as it travels through the port of the loop that is buried underground. Once it gets back above the ground, the warm water or refrigerant transfers heat into the building. The water or refrigerant cools down after its heat is transferred. It is pumped back underground where it heats up once more, starting the process again. But if it is a hot day, the system can run in reverse. The water or refrigerant cools the building and then is pumped underground where extra heat is transferred to the ground around the pipes. There are many advantages of geothermal energy, but also some challenges that need to be overcome to fully exploit this natural resource. In this section, we will be talking about advantages and disadvantages of geothermal energy. Here are some of its advantages. Geothermal energy is, first, reliable. Energy generated from this resource is easy to calculate since it does not fluctuate in same way as other energy sources, such as solar and wind. This means we can predict the power output from a geothermal plant with a high degree of accuracy. Then, renewable. Geothermal energy is a source of renewable energy that will last until the Earth is destroyed by the Sun in around 5 billion years. The hot reservoirs within the Earth are naturally replenished, making it both renewable and sustainable. Third, sustainable or stable. Geothermal provides a reliable source of energy as compared to other renewable resources such as wind and solar power. This is because the resource is always available to be tapped into, unlike with wind or solar energy. And then, environmentally friendly. Geothermal energy is more environmentally friendly than conventional fuel sources such as coal and other fossil fuels. In addition, the carbon footprint of a geothermal power plant is low. While there is some pollution associated with geothermal energy, this is relatively minimal when compared to fossil fuels. Here are some of its disadvantages. Geothermal energy is expensive resource. Geothermal energy is an expensive resource to tap into, with price tags ranging from around $2 to $7 million, or in peso, it is equivalent to 97 to 340 million for a plant with a 1 megawatt capacity. However, where the upfront costs are high, the outlay can be recovered as part of a long-term investment. Then, it is location dependent. The largest single disadvantage of geothermal energy is that it is location specific. Geothermal plants need to be built in places where the energy is accessible, which means that some areas are not able to exploit this resource. Of course, this is not a problem if you live in a place where geothermal energy is readily accessible, such as Iceland. Then, emitting greenhouse gases. Unfortunately, no matter its reputation as being an environmentally friendly alternative energy source, geothermal energy also causes some minor concerns in regards to the environment. The extraction of geothermal energy from the grounds leads to a release of greenhouse gases like hydrogen sulfide, carbon dioxide, methane, and ammonia. However, the amount of gas released is significantly lower than the case of fossil fuels. And that ends our lesson for today. Thank you for tuning in. See you again next time for another scientific lesson. Always remember, science is not just amazing, it is fun. Again, this is Teacher Joy. Bye!